Hello and welcome. My name is Frank. I'm a passionate Rhapsody user, trainer and coach and love to share my experience to help you to become more effective. In this video, I would like to give an introduction into SysML Parametric Modeling and how this can be performed in IBM Rhapsody. In this first video, which will be the starting point of a series of videos about this topic, I'm going to show you the very initial concepts to get started with parametric modeling in SysML and how parametric constraints can be evaluated in Rhapsody in conjunction with mathematical tools such as Maxima. An essential part of the systems engineering activity are different kinds of analyses and studies, like trade-off analysis, to compare and investigate different design solution approaches. Starting with the evaluation of the architecture in terms of feasibility, reliability, up to the evaluation of the lifecycle costs of the system under consideration. All this in order to find the best potential solution for a specific context and goal. These analyses are supported in the SysML by the so-called parametric modeling, which allow you to build mathematical relationships between properties of blocks in the context of your model-based system engineering activities. To support the construction of parametric models, SysML introduced the constraint block. A constraint block is a special kind of block allowing you to define equations called constraints with parameters of the equation that can be bound to the properties of the system being analyzed. So constraint blocks have two main features: the constraint itself, which is an equation in form of a mathematical expression, and a set of constraint parameters, which are the input and output values for this expression. Constraint blocks and their relationships can be defined and visualized on block definition diagrams. This is similar to the way blocks are defined. With this concept, we are able to define a constraint block with its constraint and its related parameters once, and we can use it in different contexts thereafter. And similarly, the paths represent usages of blocks. The constraint property is a kind of part which represent the usage of a constraint block in different contexts. The usage of the constraint property is configured and shown in the parametric diagram, which is a special kind of an internal block diagram. While the BDD diagram shows a definition of the block and its relationships, the parametric diagram shows the use of constraint property and how it is connected. The block which owns the constraint property is also the owner of the parametric diagram. In the parametric diagram, we connect the value properties of the owning block with the constraint parameter of the constraint property. The connection between the value properties of the owning block with the constraint parameters of the constraint property is called binding connector. The name of the value properties and constraint parameters can be different, but they must be of the same type. Let's take a more detailed look onto the constraint itself. The constraint is a mathematical expression. SysML does not have its own language to describe constraints, but that's okay. Depending on your domain, you have the flexibility to use different constraint languages, such as Object Constraint Language, OCL, C, Java, or MathML. Or you can use the language of tools, such as Modelica, MATLAB, or Maxima, which has another huge advantage. Because once you have created a model with such a language in Rhapsody, you can directly connect to these mathematical modeling tools to evaluate the constraints. For example, have a result calculated based on input parameters in your model. This concept is also known as Parametric Constraint Evaluation. And this is exactly what I'm going to show you today. In this video, I will take Maxima, which is a free open source computer algebra system. Besides symbolic computation, it has many other capabilities and can be used in many use cases. The linkage, the integration between IBM Rhapsody and Maxima is realized via the Rhapsody Parametric Constraint Evaluation Profile, PCE in a short, which can be simply added to the Rhapsody model. With this, we can feed our SysML model with values, and the tool calculates the results. These results can be fed back into the Rhapsody model to serve as basis for further calculations. I will show you this in a demo in a minute. A very remarkable point here is that this profile is available for all Rhapsody editions, as well as in the Willard Embedded Studio. So in case you just have Rhapsody Architect, for example, the Rhapsody Low Cost Entry Edition, then you can already perform these kind of evaluations, which is extremely beneficial. Let's come to the demo. The model for the demo I'm going to show you is an extract from the book SysML for Beginners using IBM Rhapsody. It contains a simple cylinder block from which the volume shall be calculated. Further information can be found under the link given. The best practice is to manage constraint blocks in a dedicated constraint library. As an example, I have a constraint block defined here, which contains the equation to calculate the volume of a cylinder. A block definition diagram is used for the visual representation of the constraint block. The system of interest for the analysis shall be this cylinder block. For this purpose, it is composed of a constraint block volume of cylinder for the further calculations. The cylinder block represents the context of the analysis. In its parametric diagram, we connect the value properties of the cylinder block with the constraint parameters of its constraint property. To connect Maxima to IBM Rhapsody, we use the, as mentioned, PCE-Profile, which we add to the model via Add Profile to Model. Before using it for the first time, a setting window pops up in which you only must set the path to Maxima. The profile offers different stereotypes and associated functionalities that we can now use. To evaluate the parametric diagram, we have to add a constraint view. This view is a link to Maxima. In the constraint view, we reference our parametric diagram, which shall be evaluated. For the further calculation, it is useful to feed the model with values. In this simple case, I'm going to compare different instances or variants of cylinders. So I can directly put initial values to the value properties of the block itself. I leave the volume empty because that is what we want to calculate. If I want to compare several variants, for example different cylinder sizes, I would rather use a so-called instance specification. The use of instance specification and more complex composite calculations are a subject of further videos. Now we can open the constraint view to start the evaluation. Via evaluate, the constraint gets calculated and we get the result of the volume. If I want to return the result back to the model, I simply click on Update Model, which writes the calculated result for the volume into the model. I hope you enjoyed this first insight into parametric modeling, in which we defined and explained the basic concept of parametric modeling with SysML and how these models can be evaluated in Rhapsody with Maxima using a simple example for illustration and easier understanding of the concepts. In the next videos we will calculate more advanced concepts and more complex examples, so stay tuned and don't forget to subscribe. Hope to see you soon, thank you and goodbye.